This video covers Section 3.4, Slope-Intercept Form of a Line. Objective 2, graph a line whose equation is in slope-intercept form. We have seen the point plotting method for graphing a line. I always feel blind going into those, and I don't know which x values to use. To graph a line using slope-intercept form, it becomes much quicker and easier. The idea behind this is the slope-intercept form of our line. We can see here that m is 2/3 and b is equal to -4. So our slope is 2/3 and our y-intercept is 0, -4. So to achieve this, number one, we're going to start at 0, -4. We're going to locate that point. And that's where everything starts now from. Step 2, use the slope, rise and run, to move to other points on the graph. So we have a slope of 2/3, rise 2, and run 3. That looks something like starting at any point, you rise 1, 2, and then run 1, 2, 3. Continue that way all the way until you get off the graph paper. So at 0, -4, we rise 2 and run 1, 2, 3. We rise another 1, 2, and run 1, 2, 3. Rise another 1, 2, and 1, 2, 3. And we've got room for one more point, 1, 2, and 1, 2, 3. Now, to get the points on the bottom left, we change the slope into something that's equivalent to it by both negatives. -2 over -3 says now whatever point you start at, you're going to drop 1, 2, and run left 1, 2, 3. This will allow us to stay on our line. So from the point 0, -4, I drop 2 and run 1, 2, 3 to the left. I drop 2 and 1, 2, 3 to the left. Drop 2, 1, 2, 3. And I've got room for one more, 1, 2, and 1, 2, 3. Connecting those dots using a straight edge. And that's how you efficiently graph a line. It is always a good idea to take one of these points that we found by plotting points by using the rise and the run. So let's plug in x equal to -12. Using the original equation, y equals 2/3 times -12 over 1 minus 4. 3 goes into 12 4 times. 2 times -4 is -8, minus 4 is -12. That is what I expected, and that tells me that I have done a great job getting the graph correct. Example 6. If the line is already given to you in slope-intercept form, we're ready to go. We see that the slope is -3. We see that the b is 2. So we label our slope as -3/1, rise -3, run 1, and the y-intercept is 0, 2. Let's start at the y-intercept at 0, 2. Let's place that point on our graph. Step 2, use the slope to move to other points on the graph. If the slope is -3, we write it as -3/1. So the rise is -3 and the run is 1. Remember, negative slopes drop as we move left to right. So if we rise -3 from the starting point 0, 2, we go down 1, 2, 3, and run 1. Keep going down 1, 2, 3, and run 1. 1, 2, 3, and run 1. 1, 2, 3, and run 1. Now I want to get points up in the upper left, so I change this slope and I put the negative in the denominator instead. And now the rise is a +3 and the run is a -1. So I rise 3, 1, 2, 3, and run -1. Rise 1, 2, 3, and run -1. Rise 1, 2, 3, and run -1. And now I have all the points on my graph. I just want to check one of these points to make sure it works, and I'm going to check this one here. That's over 1, 2, 3, 4. So if I plug in x equal to 4 into this equation, I should get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, -10. So the equation says y equals -3 times x plus 2, and if x is 4, that's -12 plus 2, which is -10. Just a double check there to make sure I've graphed my line correctly. This concludes the video for section 3.4, slope-intercept form of a line, objective 2, graph a line whose equation is in slope-intercept form.